Okay, thank you everybody for being here, first of all. So happy to have everybody here and also meet up here, first of all, in Italy, and second of all, here at Datapizza offices. So today I want to talk a bit of how we use affected Datapizza and focusing on services and layers in production. I'll do a quick introduction on what we build at Datapizza in general and what our team builds. Then I'll explain a bit on why AI is so useful in today's world, of course, but most importantly, how we use AI and how Effect becomes a superpower with AI. Then I'll do a quick intro on services and layers for who is not familiar with Effects. And then I'll give a couple of concrete examples and another specific use case that we have in our code base. So I'm Leonardo Trapani. I'm founding engineer here at Datapizza. As a side project, I'm also a university student, but it's not very important. So what do we build at Datapizza? Our vision is to make Italy a leading player in tech and AI, and we try to do it by creating an ecosystem that helps companies through AI transformation. So we both teach companies how to manage AI and adopt AI, but we also have done a lot of custom projects and R&D projects. And in all these projects, there are usually some type of requests, which are the usual flows, like on a new ticket, create a PR automatically, or answer customer questions about their insurance policy, and many others. And there are many ways to tackle this problem. One is custom AI projects, the one we've tried up until now. And it's very good because it really fits the company data, it fits the company infrastructure, it fits the company itself. And so it's very easy to go and know what you need to build and just build it. But the problem is that it's a bit too expensive. For many use cases, it can be repetitive. It can be useless to just start over an entire project, know how to host it, build a front end. So people have started building generic agent platforms. There are many, even though not really. They have agents, workflows, ways to manage them, ways to give observability, guardrails, and to deploy agents. The problem is that they're not really integrated into the company. It's very hard to, first of all, self-host it, but second of all, integrate it into the company infrastructure. And as we all know, businesses rarely use standard software like Jira. In Italy, it's even more than the average, I'm pretty sure. They always have a custom API that you can access only if you live in Africa, for example. So we thought about Dual. Dual is a company-shaped agent platform. So the platform provides agent orchestration, workflow execution, and many more features that any agent platform should provide. But we also integrate very well with the company infrastructure and the company systems. And we actually believe that we need people going in there as the famous role, the forward deployed engineer, and actually integrating the system and making it work well inside the company services. So it's the platform that adapts to the company, not the other way around. Now, we've talked a bit in the previous talk about AI and how Effect helps it. Now I want to talk about boundaries that I can follow in specific. There's this great talk that everybody should watch from Matt Pocock, which is Principles for AI Coding. And he basically says that software fundamentals matter more than ever. And we believe in this a lot. First of all, they're from a very famous book, A Philosophy of Software Design. I want to provide a definition of complexity. A complexity is anything related to the structure of a software system that makes it hard to understand and modify the system. Usually, there are two ways to build modules. There are shallow modules, which basically means we don't really think about how the code base and the architecture of the code base is structured. There is not much functionality, and the interfaces are very complex. The surfaces through which different modules talk to each other are very complex, and the implementation is not really hidden under a layer. Instead, deep modules hide the complexity because they're hidden under a simple interface. There should be a very easy and simple interface that hides a lot of complexity into the implementation. So this is how shallow modules look. They're just very little software boxes that talk to each other. And this is the problem. It really creates complexity. It's a piece of code talks to another. So to understand the entire flow of the application and the architecture is just complex by the definition. And agents do not thrive in complexity. First of all, they are very good at creating complexity. Whenever there is a bit of complexity in the code base, they just keep doing it and keep creating it. And if the code base is not structured in a well-architectured way, it's just going to keep going. If you try to vibe code a project, after 1 or 2 days, it's going to have exactly this pattern. You ask it to create a little functionality, and it just keeps going and keeps connecting things. And you see the same function written 20 times, and to check and do a query on the DB, does it 20 different times, and authorization and all this stuff. This is a deep module instead. The software is blocked in little boxes, actually in big boxes, and there's a very thin layer, which is the interface. The interface is how these different pieces talk to each other, and it should be very simple, and the complexity should be constraints and be into the implementation, so not really the service, which is how they talk to each other. Effect forces you and your agents to follow good software fundamentals. And now let's get into what services and layers are and how they actually do that. First of all, another little definition of what dependency injection is, I hope many of us know what it is a software design pattern used to create loosely coupled code. And it's a pattern that Effect uses extensively, and it's the way that lets us create this loosely coupled code and these deep modules, because you can define the interface, and then the implementation is just a swappable dependency. First of all, what is the effect type? The effect type is the description of a piece of program. It has 3 type arguments. The value channel, which is just the return type of a function, basically, if you look at the promise word. Then the particular thing is that it describes errors. So in every point of the code base, you don't just know what the function returns, you actually know what can go wrong in the single moments of the code base. Then there is requirements, which is green because that's pretty important for my talk, and that's services. It's basically a definition of, okay, we talked about dependency injection, what dependencies do I need to actually run this piece of code? With Effect, your deep modules become explicit, type-safe, testable, and swappable. Let's have a bit of context so we can even compare it to what we're actually building. So dual. What is a capability? A capability is a tool an agent can use or a block in a workflow. It can be, for example, Gmail send email. So it can be send an email, and you have to define through an SDK what is the inputs and what is the output schema. There's even error schemas, many more, and the implementation, and of course permissions and many more things you can define. So it's basically, okay, an agent or a deterministic block in a workflow can do this particular thing. Now, how can we build a registry for these capabilities through, for example, services and layers? First of all, you define the service. In the service, as you can see, you basically just declare an interface. You declare this is the interface. You can communicate to this deep module through these methods, list, search, and invoke. And as you can see, it's very useful because you don't just know the return type, which can be a list of capabilities, but you also know that, for example, when you invoke a capability through an ID, for example, you could not find a capability, or you can there could be an input error or many more errors. And this is very useful because when agents with a limited context window go and edit something, they don't need to look at the specific implementation to know what can go wrong. But you can actually define through these boundaries even what can go wrong, which you can abstract from the implementation and include in the service itself. How do you use a service? You can just yield things, saying in effect, and you just yield the service and use a function. since this invoke capability by ID is an effect, this that you can see at the bottom is the type of the effect. And you can see it returns capability results, which, as we just saw, it declares the errors that it has. So it infers them from invoke, and they bubble up, meaning that if you use another effect uses this effect, that's gonna have those errors as well in the error channel if they're not handled. And then in the third argument, line 15, we see a capability registry, meaning that we also declare, okay, this effect is using a capability registry, then we need to provide it. We need to give the actual dependency, the implementation of the registry you want to build. Squiggles are your best friends, meaning that through these feedback loops that the agent uses, like the type checking, if you use the actual effect we just created, it's gonna give an error. It's gonna say, you're using an effect, but you didn't give us the actual implementation. Like you're talking to a module, which is the capability registry, but what even is the capability registry? I can know what it is. So how do you give the implementation? Through layers. Layers are, first of all, they declare the actual implementation. So they just take the actual methods and declare the implementation. And second of all, they can merge and use other services. As you can see here, this layer uses a DB service, for example, and a dual service, but let's not focus on that. And through the database service, it means that automatically, to use this specific layer, you need to actually also give the database layer. And you just compose them through a very clean API, which is so easy to look at and understand where things are provided and where dependencies are given. And in this example, we just take the capability registry implementation we just saw, and then we merge and give it itself, since it has the requirements of the database service, we give the database implementation as well. And through just effect.provide, that gives implementation, and then you can just run the promise without any type checking error. And we can really see how this resembles so much with the deep modules we just saw. The top line, the interface, is just the service, which is the explicit boundary, and then the layer is just the injectable implementation. And they're type safe, explicit, injectable, and swappable. Now let's look at a couple of examples of where this pattern occurs. First of all, let's look, for example, at the HTTP API group. So the HTTP is a library, is in the standard library of effects. It has many libraries. You can probably find anything you're looking for. And in this example, we just define basically the boundary again. We just define what is the structure of this API. How do you talk to this API? There's a payload, it's a get, there's a success, and an error. You don't actually define here the implementation. This basically defines a service. It defines what's the structure of how you talk to the program. And then, of course, you also need to give it as a layer, as the implementation. You provide the actual implementation, which are the handlers. Another example is our capabilities. This is an internal SDK that we use. And here as well, you can just, first of all, you define a provider, like Google, it's what we call a provider. And then in this case, let's look at Gmail Send. As you can see, we just define there's an input and there's an output. We don't actually define the implementation here. Then we do, with the syntax toLayer, we just construct the actual implementation and we give the layer. And again, this is type checked. Now, let's look at a very specific implementation and very specific thing we need and why Effect is perfect for that. Our promise for building Dual is this platform will be built around your systems. Then companies come and say, great, now build it around our system. And it's never that easy. They usually say our LLM gateway runs in an Azure tenant. We give you our sandboxes, or they want the credentials not in a DB, but in a secret vault. And if you, again, don't follow good software fundamentals, if you just keep prompting an agent, right now it's probably just gonna do something like this, which is extremely ugly. You don't use any dependency injection. You just check the client or some options, and you just construct the things. Instead, you can since everything is so declarative and explicit in the type system, you can just have an effect like the dual.run server, and in that effect, you leave some dependencies, you leave some requirements, meaning explicitly in the start, in the effect, you say, okay, this effect still needs a queue service, a credential service, a model gateway, a sandbox service, a static service, and telemetry, for example. And this is so good because if we have, for example, different teams of forward deployed engineers integrating these, we can't really go there and say, oh, okay, now we need to provide actually the credential service as well. I didn't know it, you didn't tell me, you added a new feature. Or for example, how do I create the credential service? Do I need to look at and handle the errors myself, or are they handled by the program? And this is so good because it's so explicit. So then you just merge together the services, the layers specific to the company, and you just provide them to the actual program. And you can just run the specific implementation of the client without having too much trouble, and knowing that if the type system passes, then you have implemented it basically correctly. Thank you for listening. I hope you liked it.